Okay, let's continue with the terminal emulator. So this morning we started reading in data from the terminal, and also we started sending some data to the terminal. So but we can't really display it properly yet or parse it. So I think before we start sending more input to the terminal, what we will do is start to parse it. Now there's two ways you can do this. Maybe the most obvious way would be to just read it in character by character and act based on a giant like state machine. Now the problem with that is that it's like really slow. If you go to like blit a ton of text to the terminal really fast, that method is kind of bad. And also that method doesn't lend itself well to like adding features like scroll back. So if you want to scroll back and you are just parsing line by line, and you try to, or sorry, and you're just parsing character by character, and you try to go back one line in the text, you don't actually know how far you have to go back because a line could be like an arbitrary number of characters. You don't really know how long it is, so you don't really want to do that. Instead, what you'd like to do is sort of like maybe pre-parse the input and just like chop it up into lines. And then when you go to display it on the screen, you can display it by going to the line buffer and then grabbing like as many lines as you just think you need and then just drawing those all on the screen. So let us start doing that. I think we're going to do that in a new file called terminal.c. I really want to call it like vt100.c because it's not really limited to vt100. So I'm going to have a function here that's going to be called it's going to return a size and it's going to parse split raw input to lines. Now, split raw input to lines is going to take I'm not sure if this makes sense, but there could be like a type that's like ring buff view, but that's also just the same thing as an S8, like a slice. So probably it's just going to take a slice. I don't think it's going to make anything harder. So view raw. It's also going to need to know about some things. So it's going to need a line buffer to output to. It's also going to need to know about the ring buffer itself. And it's going to need yeah, okay, so let's just do this first. Let's just do a line buffer. So let's pass in, let's see how I did this before. How I did this before was pretty good. gonna do something similar. So we're taking like a range and we're taking remaining bytes as an output. Okay, yeah, I remember now. So remaining bytes here, we're gonna take that as a parameter as well. So what happens if you are parsing something and you didn't receive all the data that you needed? So you decide not to parse the full range of raw data. You need some way of indicating that there should be more. The next time you come through, you should use some of the old data from the previous round. So that's why we're going to store this output line thing. So here we're going to have this variable. So this variable is parsed lines. Start out at 0. We kind of need the terminal state. Well, let me just think here. So I don't think we really need the terminal state just yet. We might add that stuff to here after. But we are going to need like a line buffer. Like the only reason I'm thinking of passing the terminal state to begin with is because I already know that when we go to parse and we get the escape code that basically tells us to go to an alternate screen, we need to do some stuff with the terminal. So like we're gonna need to shuffle some data around, which is a little bit non-ideal, but it just has to do. So I don't know. I think for now we're just going to start with assuming that we're not going to the alt screen, and we'll add that feature after. So we're going to take our raw, we're going to take our remaining bytes, and we're going to take a new type that I'm going to call a line buff pointer LB. Yep. Now a line buff, we're going to have to make that type. We're going to have to make that type. So ring buff. This is going to be this is going to be another ring buffer, but it's, excuse me, it's going to not contain, it's not going to be like a hardware ring buffer, because it's kind of pointless and you don't need to make it like that big. Though you could. It's just, yeah, I think it's not useful here. So first we need to actually have a concept of a line, have a line buffer. A line is going to be, oops, pointers into this ring buffer. It's going to have a U8 pointer start, U8 pointer end. We have a start and end, and then let's have a look. Yeah, this is useful, like a value that just tells us if there's any Unicode in the thing. So maybe like that a Boolean would be 32. as Unicode. So if there's any Unicode in the line, we have to handle the line differently. We'll have to go through and do like a UTF-8 reader kind of deal. But if it's just ASCII, like if it's just all if it's all just ASCII characters, we don't have to do like the more expensive handling when we go to blitz the screen. So that's like a useful thing to have. And then we're gonna have a cursor state. Right, so the cursor state is going to be important. We want to store whatever the cursor state is when we start a new line. And the reason is because if we go to do scroll back after, we don't want to have to replay the whole like sequence in reverse to figure out what the state of the cursor was when we started the line. We want to just be able to grab something that tells us what the cursor was at the start of the line. So that means that we have to have a cursor. Yeah, so everything here is just fine, I think, with the cursor. It's going to have a color, a foreground and background color, the cursor state, I mean, and it's going to have a cell attributes. So cell attributes are anything like bold, blinking, italic. There's a few other ones that we'll get to when we start looking at the actual data. Probably I'm just going to copy this stuff because I think this stuff is useful. This cell thing may or may not get copied. I think these, though, are kind of important. Let's put those up here. So, okay, so we're going to have a cursor. Do we have a U16? No. Honestly, these can just be U32s. Yeah, we'll just use U32 for that. And we're going to need to have some enumeration of the cursor stuff. I wonder if there should be like a terminal.h or something going on here so that this file doesn't just keep going on forever. The problem with having a terminal.h is that it then has to include other definitions, which can be annoying. I think we're going to go with the big bloated single header for now. Enum cell adder. Enum cell attributes is going to be adder null. Just gonna set that one for now, and we're just gonna ignore the other one, everything else. This can just obviously be a 0, and then maybe I'll even be explicit about that. And then we're gonna do this. We're gonna have our cursor. We're gonna have our cursor state. We actually don't need the, well, the terminal is gonna need to have a cursor at some point. So we're gonna add the cursor. Yeah, we'll add the cursor. And it's going to need to have a line box log lines. Okay, so we've got the cell attributes now. So now we can store the cursor state. what did I call it here? Just like state, cursor state. I'm gonna call it cursor state. Okay, so each line is gonna have a start position in the ring buffer, end position in the ring buffer, a Boolean indicating if it has any Unicode, and a cursor state. So the cursor state at the start of the line. Then the line buff is gonna be an array of lines. What did I call it here? I don't think it matters, but yeah, we'll just call it buff. And then it's going to contain a size, which is the capacity, size filled. It should all be semicolons. And a size right IDEX. Basically identical to the ring buffer. Except for the fact that it is not going to be well, it's like an array of lines. It's not an array of bytes. I guess that's like the primary difference. Now we're going to need to allocate that at the start. So let's close this. Let's open the main file. And in here, we're going to have to add a function that is we're also going to include the terminal. Probably we'll just include it in here as well. Okay, so building, that crashed because we changed the layout of the struct. We'll close that or just restart it, I guess. Got that going. Then what we're going to do is we're going to allocate some space for this line buffer. So we're going to do where did I do the arena? Oh, right here. Okay. Yeah, it's fine. We're gonna do that, and we're gonna do line buff alloc term.line term.log lines buff is gonna be equal to line buff alloc. A number of lines. Let's say we're just going to keep 1024 lines to start with. There's going to be like a scroll back of only 1024 lines. Potentially that's good. Maybe you want to make it bigger. The problem is like there's like a bit of a problem where like if you make it too big, then you could never fit that many lines in the ring buffer anyways. So if you scrolled back that far, you just end up seeing the same data getting repeated. So we'll start with 1024. Yeah, okay. And then we'll have a function up here that just does that. Except it's not good. It's gonna take the arena. So we're gonna start running out of space in this arena, possibly. Though I haven't decided yet. So let me see. So if we do BC and we do so a line is going to be 8 bytes, 16 bytes, 12 bytes, 16 bytes, 20 bytes, probably 24 bytes total. So that, yeah, that would make sense. And that's like three 64-bit registers. That's actually good. So yeah, so probably 24 bytes total. Assuming this gets assigned to be like a U32. So if it's 24 bytes total, we're gonna say 1024 times 24 is 24 kilobytes. Okay, never mind. Ignore what I said. It's only 24 kilobytes. Yeah, that's fine. We're not gonna be running out of that space just yet. Okay, so line buff alloc. Take an arena pointer A and a size capacity. Actually, this is going to be better if it takes a line buff pointer LB, arena pointer, and a capacity. Oops. Okay. So what we're going to do here is we're going to say LB to cap is equal to capacity. LB to filled equals 0. LB to right IDEX equals 0. And LB to buff is going to equal alloc A align capacity. That's going to give us our line buff. Okay, so we're going to restart this. Oops, so that we actually get that line buffer allocated. So I'm going to go back to the terminal.c now. Yeah, so we're going to split raw input to lines. And we're going to take this, we're going to take our line buff, we're going to take that all that stuff. And we are going to, in here, what are we going to do? We need to sorry, just having a brain dump there. We're going to need to use SIMD for this. So just basically, oops, you don't want that one. Basically, we're just going to copy most of this stuff from the old one because I know this part of the old one is good and I don't want to rewrite it all necessarily. We're going to have to chop some stuff out though. Okay, so let's take this. Gonna need some stuff like this. So we're gonna need a mask that is basically just all new lines. We're getting a mask that's all the escape character, which is 0x1b. And we're going to get a mask that is going to help us decide if there's Unicode. So basically, if there's Unicode, we can just, or actually this is by definition, if there's like UTF-8 text just embedded in the file, or in the data, sorry, some of the bytes are going to have this highest bit set. So that's what this mask does. This mask is just like the highest bit of a byte, just set. So we're going to fill these up into vector registers. So there's actually going to be 32 of these ones per thing, right? 128 divided by 8 should be 32. I'm not dumb. 16, good. I should know how to do math, I don't. Anyways. Sorry, so 16, we're doing masks of 16 bytes at a time. And we're gonna do the while raw.len. We're gonna have a second one. Have some more stuff here. So actually I'm just gonna copy not all that. Just gonna copy this inner part of this loop. There's a bunch of stuff in here that will have to get chopped up. So, okay, so first of all, as UTF-8, we're just gonna get like a zeroed register. This is probably a good idea. So some programs are gonna send like really long lines with no new lines in it. And if that happens, you don't want your terminal to just like I'm actually like questioning if this is even a useful concept because it can kind of complicate things if you split up the long lines. And whether or not it's necessary is completely kind of up in the air. So let's for now just not do that. Yeah, I don't know. I'm like debating if I should be splitting up long lines or not. I think it's probably a good idea to split up the long lines. We will test this later, but we'll not 1024, 4096. So we'll split lines that are longer than 4K. So this is going to be raw. The data pointer is just the raw thing. Then while the count is greater than 16, because we're using SIMD registers, we're going to load in the data into a vector register. We're going to construct a mask that indicates if that line contained any new lines, or like if this 16 bytes contained any new lines. If this 16 bytes contained any escapes, if it has any Unicode, and we're going to make a mask here that tells us if we need to do any processing, which is just going to be an OR of does it have any new lines or does it have any escapes. Then we'll go ahead and we'll do this move mask EP8, which is basically it goes and what does move mask? Let me just check actually. So move mask, I believe move mask just does yeah, it basically goes ahead and says it takes the most significant bit of each 8-bit thing in this register here, this hasPro variable, and then it puts those all into like a 32-bit dealio with without spacing. So then we're going to say, okay, if we do need to process the data, we're going to figure out how far we need to go. So tz count will go even in here, right? Tz count. So yeah, tz count 32, or u32. It counts the number of trailing zeros. So basically we go and say, going from like the least significant bit up, we want to find the first bit that's just set. That's what we're doing here. Then we're going to construct a mask, which will let us decide if there is this kind of looks like there might be like a mistake here actually. I think we should have another. I think we need to have another OR here. Because we should be going into this has process, like needs to be processed loop, sorry, needs process, if Unicode is set as well. Okay, so then we're gonna have this UTF-8 overhang mask. I'm gonna have to make that as a static variable. Cool, this UTF-8 overhang mask. It's 32 bytes long. These are all just full, like 0xFFFFF. So what we do is lower 32 are what's it called? Lower 32, sorry, the lower 16 are all ones, and upper half are all zeros. So what's happening here is we're trying to skip over, we skip over 16 minus the advance, so minus however many we need to check after the fact, potentially, and then we go ahead, we're going to load that in as a mask, and then we're going to go ahead and say, okay, out of this mask, so out of the bytes that could contain Unicode, which of them can contain Unicode, and then what is going on here? Yeah, and then we're going to store that in this has UTF-8 thing, which is been initialized up here. Then we're going to advance the count. So we're gonna decrease the count by the amount we just advanced by. So this won't be like 16 bits. It will be like 16 bytes. It will be like some portion less than 16 bytes. And we're going to advance the data pointer by that same amount of advance. So keeping in mind that what this is doing is counting like how many trailing zeros there are. So but each of those zeros represents 1 byte in the processed 16-byte data, vector data. So that's why we can just use this here. Then we're going to break from the loop in that case. And if we don't break from the loop, we're going to say, we're going to go ahead and OR this anyways. We're going to say, okay, so this uni and the UTF-8, we're going to store it. And we're going to advance by 16 bytes. So this is going to let us determine. So even if we go and process all of the data and there's no like line breaks, there could still be like Unicode in it. So that's what we're doing. We're just going to store that here. Then we're going to go to line buff at the line buff write IDEX dot has Unicode. We're going to we're going to OR in this has Unicode mask. Then we're going to add this function. So this function is basically just going to do a checked decrease in the size of raw. So we're just going to like check that we can we're going to check that this subtraction here doesn't like cause like an overflow. Or we're not going to check at all. How am I doing that? I mean, consume gets used all over the place though, so it kind of makes sense to have this as a function. Because you're gonna call this like all the time. Yeah, so we're just gonna do that, and we're gonna return raw. Okay. We're gonna want to have a peak function. I mean, technically, I guess it just returns the first byte, so never mind. So we'll do this. We'll take a range. We'll take a position to peek at to see what's in there. And we will return whatever byte was there. This is weird. We're going to comment that out for now. I'm going to delete that altogether. Okay, so then, oops. Go down here to peak. Where are we here? Okay, so we're gonna peek if the first byte. So if the first byte of the data we processed is escape, we're gonna have to do something. Otherwise, we're gonna do something else. So assuming it was an escape, we basically want to see if the escape character would move the line. That's all we care about here, actually, for now. We also care about if the screen swapped, but for now, I'm just gonna say moves line. So might change this after, but for now, it's gonna be static bool 32. Escape moves line. Or say, sorry, escape moves cursor. What else did we just pass into this one? I think we don't need this right now, actually. We're gonna consume that byte. Then we are going to want to do this. So we're going to check if escape moves cursor. If the escape moves the cursor, we're going to make a new line. We're going to increase the parsed lines count. We're going to feed a line. Line buff. We need that. Sorry, we need that. We do need that. So we need to know what like the first. Before we just do this consuming. So we want the first character on this new line to be the escape code, so we know to parse it. So we just need the pointers for that. And then we get rid of all of this for now. Feed line, init line. What's going on here before? That's correct. Okay, so this is going to be LB to buff plus LB to right index. So we're going to take the exact line that was, going to take this new line, sorry, and we're going to start it. So what on earth was this end start thing? Um, it's just gonna start at the same position. What is going on here? Let me check this. This is weird. Why is the knit line and feed line two different functions in this program? I don't know. I actually don't know why feed line and a knit line are two different things. The only problem here is that we need to know what the cursor state is to feed a line, to start a new line. So that basically argues for sending in the terminal into this thing. Now I see, okay, so this is actually a problem. Okay. Yeah, actually I need to just do the same thing I was doing before. So we can't do this escape moves cursor because the problem is the cursor could get changed by whatever escape code. And we need to keep an updated escape. We need to know what like the newest cursor is at all times so that we can use it to initialize the new line, which basically is a little annoying. But yeah. What that tells me though is that we need to not do this. This term view thing contain a cursor? And no. Okay, I don't like that at all. We're gonna pass in the terminal here. Gonna keep that. We're gonna keep track of how many bytes are remaining. This might need to get stored in the terminal actually. Yeah, this might need to get stored in the terminal, so maybe we're gonna get rid of this out parameter. And we're gonna open the util thing, and we're gonna go to term. Um, unprocessed bytes What if I just add to this unprocessed bytes member every time? That would actually make more sense, I think, than passing around like a view or a range. Yeah, I think I'm going to do that actually. That seems smart. So we are going to how do I want to do this? I think we're going to leave it like this for now. So let's do this. So let me see here. So we've got this going on. We're going to have to like do this handle escape thing. And we can just ignore the alt screen for now. I think this is like a little painful. Parse the lines. Actually, I need to look at what this weird -1 case was. Right, yeah, I know. I do know. Okay, so handle escape should basically return 1 if the cursor moves. -1 if it needs more data. And 0 if... Is there a case where it can return 0? Yeah, 0 if it's just I should basically have this return like a enumeration type. So we're gonna have this handle escape return. We're gonna have Needs more bytes. Cursor moved. Normal return. So handle escape should take a raw data. Now the integer in here before was whether or not it should allow the screen to swap. I think, let me look at how this was being used before. Handle escape. Sorry, here we go. Oh, sorry, allow the screen to scroll. That's weird. This is rough. We're gonna punt on that one for now, on that part. Okay, so we're gonna do this, return, result equals normal return. And let's see here. So I'm gonna need to okay, so let me see here. Otherwise, the cursor moved, we're going to increase the parse lines. We're gonna here to this, we're gonna feed a line. Basically, we're gonna terminate the old line. And start a new line. And we're gonna ignore this. And we're gonna break. So then here, okay, so in this case, okay, so this one, let me just make sure this all looks good. We're not taking this part yet. It should be yeah, this should take a pointer to the raw so that it can modify like the remaining, modify whatever is remaining. Do this. This all looks good. Okay, so assuming all that goes well, the next thing we're gonna do, so let's say we didn't find an escape. We didn't find an escape, and yeah, we're gonna get we're gonna grab one ASCII character from the finger here. That sounds weird. Oh, I know what it was. Okay. Get ASCII. Technically, we could include some like assert here. Probably we did. Then we're gonna consume one from the count, and we're gonna return the result. Okay. So if there was a new line, if it was a new line that caused us to break from the previous loop, we're gonna increase the parse lines count, and we're gonna feed a new line. We're gonna start a new line. We're gonna go line buff raw.data. Otherwise, if it was a Unicode, we're gonna set that it has Unicode. And set the bool that indicates that there could be Unicode in the line. And then so let's just review quickly what's going on here. So process bulk 16 things at a time. If we parsed a line, we would have fed a new line. Also, I think we switched this to pass in a term. So let's do this. Oops. Do that for now. So here, let's see. This to me looks like it's completely kind of pointless. We're going to set the end pointer. Then we check if the new end pointer is less than the start. Maybe a bug here, but I'm gonna delete this part for now. Oh, I see. So yeah, this part, I don't really know what's going on there. LB to buff, LB to right index dot end equals. We're gonna do that first, and then we're gonna check the line length. We want to check if the line is greater than what we were supposed to split at, we're going to split it and then continue. Okay, let me just write this function. I don't know why this assert is here. So yeah, assert that the start is less than the end. Okay, this should work fine for now. If we get some new lines, so let's see. Oops, that is dumb. Wait, what did I do? This isn't C++. Okay, feed line, we have to write that. U8 pointer position. LB to buff. Right index plus plus going to equal the end position is going to equal the position. Then the right index, sorry. So if the line buffer to right index is greater than or equal to the capacity, we're going to set it to 0. Otherwise, we'll just keep it the same. if the right index is less than so if the count is less than the current right index, after we've adjusted the right index to account for wrapping around, then we can go ahead and add some new things. But if the right index wrapped around, so then the old count would be at capacity, and the new count, so the old count would be at capacity, and this is going to be like 0. And then this will never add, this won't add anything extra after that point. And then we're going to do this init line, which yeah. What did I call that here? It wasn't called that. It's cursor state. And we have to get the cursor in here. This is going to be a cursor state. We'll just pass it in. Cursor state. We'll just call it cursor state so I don't make a dumb mistake later on. Okay, so then feed line. We called this build. Okay, so that's all building now. I'm gonna take a break in a second here, but let's just go into here. Instead of blitting the text, what we're gonna do is say, first of all, here we're gonna go term key to unprocessed bytes plus equals this. And then we're gonna go ahead and call I think I'm missing a section here. Yeah, so here okay, so let's construct this. It's this thing. It should be this. Might restructure this in a second here. It's this log to buff minus unprocessed. It should be plus the right index minus this. And then we're going to go ahead and do split raw input to lines. We're passing in t, and we're passing in this raw. Okay, so let me make sure this thing compiles now. It's not getting used, that's okay. So, I'm gonna close this. We're gonna rerun it, but we're gonna do this first, just to resolve the symbols, and then we're gonna close, and we're gonna go to the correct file here, and we're gonna break in that function here. Okay, so we're going to step over this one. T to unprocessed bytes. Something happened there? What happened there? I think I forgot to. I was trying to get the build working without debug, and I did not turn on the debug symbols again. Okay, so this will work a little better. So it was just getting optimized out. That was what the problem was. Okay, so if we go in here now, and we look at this raw, we've got 17 bytes, and it's got some escapes in it. So we're gonna step through this. We get our log lines, parse lines is 0, some masks. There's some len, we're gonna get that. We're gonna parse 17 bytes, get the data. Count is greater than 16, so we'll go in here. Need proc is some big value. That's not really helpful for reading anyways. So we'll step in, we'll get this. there's 0 because there was a 1. So it's like the first byte that needs to get processed. So we'll do this mask. This UTF-8 mask is going to be right at the start because we had, or sorry, this UTF-8 mask is not set because the first byte was an escape character. It's not a, sorry, it did not need to, yeah, sorry, it did not need to be like parsed for UTF-8. So I'm going to step over this one, step over. We're going to do that. I'm going to break out of this loop. So here we're going to do this one. Time buffer 0 has Unicode 0. There's no Unicode. We're going to consume some data. Basically, the result was that we didn't consume any data because the data did not advance yet. And the next thing we're going to do is peek if the first byte was an escape character, which it was like escape, I mean, that specific character. We'll store that, we'll consume the escape character, we'll hop into the handle escape, we'll have a normal return for now. So we'll just break. Go to this. The line length is not. Wait, what happened there? Oh, we never initialized the lines to start with. Okay, we'll do that in a second here. Let's just. Is this gonna crash? No, okay. We'll just leave this here for now. I will be right back. I'm gonna go use the washroom and make another tea, or get another tea started. He is started. So let's see, where did I do that before? Probably there's like an init line somewhere. Yeah, here, right here. In lballoc. Okay, so let's do that as well. Except I think that's like the only case where you should be initting a line when you're not feeding it. So let's just decide if I care about making that a separate function or not. Da, da, da. Cursor state at the start will just be 0. This will be 0. Yeah, I don't think it's like worth it. Um, right here. Geez, typing, please. And this is just 0, so we'll line this all up. Okay, so do this. Oops. Okay, we'll close this and we'll go back to our stepping through. Rid of this for now. Okay, so step over all of this stuff. Yeah. Okay, and then we're gonna let's do next. So we're gonna break else end equals the current position. Should skip over that. We should go back to processing. Then we'll go process all of this. The remaining count is just 5. There's like a couple different escape characters in there, so just gonna skip over all of them for now. I could probably just use F to finish the function, but we're now down to 1, so. So we go to our line buffer now. What happened there? Why did that not get? Let me just go get the T, but why did that happen? The line, I think I forgot to actually pass the correct thing. Because like the lines should have increased. Oh, you know what? No, it shouldn't have increased because we never called feed line because the cursor never moved. Okay, let me go get the tea. Okay, so yeah, that makes sense. Let's look at the end. So the end of the line is now 15 or 16 plus 1, so it's like 17, which is what we want. If we go to this breakpoint and continue, and then we're going to do this thing I did earlier, which was cat whichever file, it doesn't really matter. So, okay, so now if we pause this, what is going on there? We pause that. Get to like a point where we can actually see what's going on here. We'll see there's 46 lines and the right index is 46. Wouldn't that be like one less than the... I don't think so. Anyways, so we've parsed the 46 lines, parsed, as in we've split the thing into lines. What if we go ahead and we just try to draw a couple lines on the screen? Also, we could... I don't want to do that yet. Yeah, so what if we can just go ahead now and yeah, let's try to draw a couple lines. I shouldn't have done that. I should have broke that first. Okay. So let's write some code here to just go through the lines. What should I call this? So we're going to close the main. We don't care about the main right now. BTGL, we're going to open this one. We're going to go in here and we're going to have a I should probably just delete this code. Especially if I want to put this here, which I kind of do. The other problem is we need to, yeah, we're still going to need to go through and process this data at some point. Probably right here is going to be fine, actually. Well, blit lines. Take a terminal pointer. It's going to take a potentially it could take a count. But I'm just thinking that I should let's just assume that we're going to blit all the lines every time. And the reason why I'm just going to assume that is because it greatly simplifies the code. Yeah, so let's just assume we're going to blit a screen's worth of lines each time. But we don't even have a concept of screen height right now. So, I mean, we don't have a concept of how many rows there are on the screen just yet. We'll leave that though. Let's just, for now, we'll just do a goofy semi-hard-coded deal here. So, blit lines. Let me think. So what we want to do here is we want to get a line. No, we want to decide how many lines to blit. For now, we're going to hard code it to 3. We're going to blit 3 lines, and we're going to do it's going to be equal to turn t to log lines. No, we're going to do this, and we're going to do clamp line count 0 t to log lines dot build. Though right now we're like making a ton of just useless lines. So I might want to fix that. Oh, it should be okay. We'll just do that. And then we're going to do I less than line count, I plus plus. Offset is going to be equal to t to log lines dot right index minus line count. This could be a problem. So this is a problem when the line buff is full, and we are now at the end. So I'm gonna just put a to-do there for now. We're gonna assert that right IDEX is greater than or equal to typing line count. And we're gonna do how do I want to do this? Here we're gonna do line offset plus I. We're gonna pass a line pointer. Where do I want to put that function? Now it's just gonna go right here. Again, we're just gonna assert that the data is just gonna equal the start. Then we have that. We can just straight up do the raw text. Raw text. Draw text. We need a position. The position is gonna start at x equals 0. So actually, I don't need to do that. And y equals t to window size. What was the window size saved again? Yeah, in the terminal. So t to window size dot h minus t to font atlas dot height minus some padding. Let's say 8 pixels. So then we're going to do this. We're going to do position line. Color is going to be green for now, I guess. That's fine. And we're gonna do that, and then we're gonna go position dot y plus equals so it's minus equals. So this should draw 3 lines if we call it from the thing here. Let's comment out this stuff. And we'll just do blit lines e. Oh, sorry, that's the GL context. My bad. Okay, so 205. Font atlas is a size. Font atlas to size.h. Okay, so let's see. Probably this calculation here is wrong. Or the first 3 lines are all screwed up. But we make this window line thing really long and we just do okay, we'll have to see what's going on there. To the debugger. Let's break this. And blit lines. Okay, so we're gonna stab. Yeah, we don't. Let me see here. Okay, we're gonna continue until this again. Oh, right. Yeah, okay. Let's change that. Let's just run this here for now. We're gonna take this and we're gonna do this blindly. We're gonna have to handle this case actually where there's only one, where there's nothing, there's no lines yet parsed. That's fine. So, okay. Let's lower this. So it'll be like the last 3 lines, which would be return this, return this, not 32. So we're getting somewhere. Got some terminal emulator going on. Okay, so next. So next what we want to do is clear to that and run this. Bring this back over for now. So if we need to draw like the thing up here. Let's just do like something like this, I think maybe. Okay, so shut up this warning for a second here. Okay, so blit lines. In blit lines, we need to handle the case where it is 0. So like since we're not actually handling the cursor thing at all right now, this should be fine. This should just work. Yeah. Let's do this again. So we should be able to see what's going on now. Then we're gonna get some plus this new thing. Be 4 lines now. We go up to like 12. Okay, so there we go. We've got stuff going on the screen. Obviously right now the font's like way too big and we're not keeping track of like how many spaces we have on the screen or any of that. Now we have to do the real work, which is actually parsing this nonsense. Let's take the win, I think. Let me see. Yeah, I'm just gonna blit the I'm gonna take the win. We're gonna take the win for blitting the lines. And then we're gonna start parsing. More and more inclined to do a terminal emulator. Having Fim running on an in-game terminal would be the ultimate nerd. Yeah, that would be fun. That would be fun. Definitely could be a fun project. So now, yeah, now what do we want to do? So okay, yeah, we're taking the win. I take the win. We're gonna delete some of this other code. Leave this part, these comments. We're gonna keep that there for now. Think about only blitting updated lines. I don't know. We're gonna do that. Just check, like, so if we launch this without it being loaded, yeah. So we do display stuff right now. So we don't really need the rectangles anymore, to be honest. Let's delete the rectangles, I think. I think the rectangles, it's time for them to go. We'll keep the functions around because we're going to use them later on, but I mean the draw rectangle function, that is, not the bounce rectangle. All of this code here, all of this is for drawing the rectangle. get rid of all of that. Get rid of that. Get rid of this bounce rectangle code. And file. Bye-bye rectangles. Now, let's see here. First of all, I also kind of want to make this font size. Let's make the default font size a little smaller for now. Yeah, not 64. We'll make it like 48. This should still be like readable, I think, on the stream. Oh yeah, that's good. Okay, we'll do that for now, just so we can get a little bit more on screen. Okay, so this stuff is good. I don't know about this thing. This may or may not be needed. Obviously this is to do. I'm gonna work on that right now. Okay. Let's add the terminal.c. We're gonna add this. We're going to okay, so we're gonna do the commit. Go to the bounce rectangle. So we're gonna do a commit. Split incoming data to lines and blit to screen. Split incoming data to lines and blit sum to screen. Alrighty. So let's start parsing these escape codes. Do I still have this page open somewhere here? Probably. So let's just increase this a little bit more. So this is going to be our saving web page here. Xterm control sequences. There is a lot of things on this page. A lot of it is useless garbage that can just be completely ignored. But a lot of it is actually important and does stuff that's useful. So the first thing we're going to want to do is start let me think here. We're going to want to parse these like color sequences. So this M here, this is 0. This, sorry, square bracket is what's it called? Square bracket is CSI. So whatever CSI, it's like control sequence interrupt or something. Can't remember what it stands for. But it's said here, but it doesn't. So it's a CSI, and then this PS is the number. We scroll past all of these until we find the M. So okay, so PM, so PS or PM. So PS is like a sequence, PM is just like a number. This is gonna set like a character attribute. So PM1 changes the cursor to bold. So that's what we need to do for that one. And then obviously there's a bunch of other ones here that show up here. Like all sorts of different ones. So let's start by doing that. That PM one is like a decent enough, easy one to start with. Yeah, so I'm gonna move that back over here. Zoom out so I can see what's going on here. And the other reason I want to just do that is because then I'll just be able to remove some of this junk from the line that doesn't need to be displayed. So let me do this. Okay, so in terminal.c, what we're going to do is we're going to go to handle escape. And we are going to, I think I just like did like sound. Okay, yeah. We're just going to want to do a, sorry, code point is equal to get ASCII raw. And we're going to switch on this code point. So if this code point is square bracket, we're going to do something. Otherwise, we're going to probably spit garbage to standard out, I think, or to standard error. So default fprintf unhandled escape code, escape care. What did I even call this here? I'd like some better word. It's like an unknown escape sequence. Yeah, that makes sense. Let's do that. Let's do unknown escape sequence. Sequence. What's going on here? Sequence. Escape. %C. And then we're also going to print it in hex in case there's an error. In case it's hard to read. So 0 to x /n CP CP. This also needs to get run when we're blitting the line. So oh yeah. There's like a few. I've got like another page open from like TerraTerm. Actually, let me just open that. And there's like WesTerm. WesTerm is mostly only useful for like the colors. I'll bring the TerraTerm one over here and just bring it on screen. So TerraTerm has like some more things. It usually has just like some extra explanation and stuff. It's like a decent enough reference as well. But the big daddy of them all is of course the Xterm one. So we'll do that. And then I need to do a couple things. So first of all, we don't want this to just be spitting out garbage forever when we're just reblitting the lines. And also, we probably don't want to just reblit the lines every frame unnecessarily. So we're going to go into, what's it called? Into here, and we're going to have a flag here. We're going to set this to t to gl.flags, and we're going to set needs blit. And we're going to add a flag for that. If needs blit, it's not if needs blit, if t to gl.flags and needs blit, we'll do blit lines, and we'll clear it in that function. And there'll be other cases when that flag will get set as well, such as in the refresh callback, which I might just enable. Actually, I'll definitely enable that one. Where are we here? We're done blitting. And then close this. Don't need that open right now. Close this for now. So set window refresh callback. We're gonna write that one now. So that one gets set like when you move something over the window or the window moves or stuff like that. Refresh. This one is just going to take a glfw win as the parameter. So we'll need to get the user pointer. We'll go t to gl.flags or equals needs blit. Yeah, this needs to be the standard error. Oh, but we're clearing color every time. Oh, that's a problem. Excuse me. Okay, we are going to get rid of the clear color. And we're going to change draw text to just clear the color behind the Yeah, it's just gonna draw a rectangle behind the thing of the size of the text. Draw text. Okay, so we need to make a rectangle here. We're gonna move this function up. This has to happen before we draw the text, though. That's a problem. Uh, let's pass in the text size. If that's the case, then we want to actually take a rect text area. So we're going to do a draw rect angle. And it's going to take the GL and it's going to take the text area. It's going to take the clear color. I'm going to have to hard code this here for now. Yeah, that's fine. Okay. I don't need that. Clear color, color. Like this. So it's gonna take the clear color. Okay, so then we've got the text size, and we've got the position. So do it like that, and then this should work, I think. Besides the area. So okay, so here. So the way I just wrote that, it's okay if like the rectangle size is 0. If the rectangle size is 0, then basically the area won't get cleared. So that's fine for now. let's just do it this way. That should work if that compiles. It does not compile because there's no size. It is text size. Why did that go bigger than that? Just close that for a second here. Right, the clear color is kind of important. That was a dumb idea. Let me think. In blit lines, we can do a clear color. Yes, I did mean that. Hello. Okay, so this is gonna fix some of the, or it's gonna be like really bad. Okay, that is not so good. What did I do wrong here? Let's maybe get rid of the need split thing. The need split might be stupid. Like not 100% sure why that text size is getting extended. Measure text, take a monospaced. Yes. Yeah, why on earth, how could that possibly be getting, how could the size of that be different if we're passing in monospaced? Oh, I think I know why. I think it's because I put a bug here. No, I did not put a bug here. Okay, we're gonna get rid of the need split, and we're just gonna keep clearing the screen for now. Let me just see, did I like, am I actually... When I redraw, I do that. let's just assume for now that we are going to be drawing the whole thing. Okay, so let's get rid of whatever just happened here. Not gonna set this yet. Get rid of that. Get rid of that. Get rid of that. Okay. Okay, so we're back to drawing something that doesn't look like garbage, but it's going to look like garbage in a sec. The reason we're only seeing 3 of these so far is because blit lines needs to actually call to handle escape as well on the line, but it's not doing that yet. I feel like that's not supposed to be an escape. Oops. Maybe it is. Okay, anyways, let's do that. So let's make blit lines. We'll just disable that warning. How was I even doing this before? Oh, right, I had this separate view. I don't want the separate view. I think the separate view is stupid. I see. The problem is if we don't have the separate view, then we have to handle characters. We're only going through the ones that we're showing, so I don't. Maybe it doesn't matter. We'll see. We'll have to check this for performance after. So here, what we're going to do is push line. I called it like play line here. So, right. Yeah, I see what's going on here. And we're going to need the terminal. So actually, let's do this way. Get rid of this part. We're going to do push line. Put that in here. Get rid of this. Get rid of this. Okay, so we're going to get SA line is going to be equal to okay, so we're gonna get that, and then we have to set the cursor state to the current thing. I don't know why we're returning anything here. What's the point of that? We're not going to deal with that right now. We're not going to return that. So, okay, so we need to do t to cursor state is going to be equal to line to cursor state. The cursor state isn't being updated anywhere yet, but it will be in the handle escape once we start doing it. And then what we're going to do is go into here. And we're going to do while L to len this. We're going to do handle Unicode case. Okay, so if we get escape character, we're gonna have to call handle escape with t does mine take here? Mine just takes a raw right now. It's gonna need to take the term pointer t. And L. And then we can just break. Default is gonna be draw a cell. This should be max font size. Need to fix that in VS. Oops. Okay, so shouldn't have just deleted that just yet. Draw cell was used before for this. Oh, I see. Okay. It's fine. We'll make a new cell. Let's go here. Let's go to okay, where are we here? Push line. So the default case, we are going to make a rect. Let me see here. So, okay, let's make a cell rect. Cell rect, it's going to be related to the current cursor position. So we're gonna have to clean some stuff up here soon. Instead of hard coding more things, I'll start. Yeah, let's start doing this. Let me see here. Static U32 get cell width term pointer T get cell height. Probably we just care about both of these, so it's maybe just going to be returning a UV to get cell size. Dot width is going to be equal to T to T to font atlas dot size dot W plus some padding. For the width, we'll do 0 padding. And then for the height, we'll do 8 pixels worth of padding. Do you want to do the padding here? I think we'll see how this goes. Get cell size T. Dot position. And dot size is going to equal cell size. Position.x is going to be T to cursor dot column times cell size dot width. And dot y will be equal to T to cursor row times cell size dot height. And then we're going to do this. Do this first, maybe. Okay, so then default is going to be I want to rename this to push cell. Push cell. So in the default case, we're going to do push push cell do this and e to gl, not push char, push cell. Vert scale is going to be crect.size. crect.position. Sorry. Push cell. Sorry, this is dumb. Not push char. Am I even using push char? I wanted push cell. Okay. Yeah, this takes a rectangle, sorry. So this one, and then for the code point, we got the code point. The rect is gonna be the cell rect. Color is gonna be, we're gonna change that to color. It's gonna be t to cursor. Actually, never mind. There's two colors. So it's t to cursor dot background and t to cursor dot foreground. And we're going to do cell rect dot position plus equals cell size dot width. Yep, that's good for now. This needs to take the term. Oops. Okay, right. I'm just gonna make this a v2. Maybe let's go here, v2. Oh, it's the state, okay. I'm gonna go to the washroom. I'll be right back. Okay, so what were we doing here? Cursor state. Cursor has cursor state, and the state has the foreground and the background. Have a look at what you're posting. Oh yeah, I know this is all this. I know this is the kind of thing gotta deal with. There's like just hundreds and hundreds of lines of. I mean, sorry, I shouldn't say that. There's just like a ton of just like useless escape codes that don't mean anything now, but for some reason, like some applications will just like output them for no reason, and then you still have to just handle them. Look at this parser thing. I don't really. Have a look at this. This is all like gross. This is all like auto-generated code. I don't really want to look at this. It's like not that bad though. Okay, so sorry. Cursor.state. What if we just pass the cursor state? Let's not do that. Okay, next. I suppose the util thing. Yeah. Sometimes C can be annoying. Cursor position dot width. Oh, we're not doing this anymore. There's our escape code spam. Oh yeah, we don't need to track that there. We don't need either of these. So let's go and kill the escape code spam. So yeah, I know that those ones are not parsed yet, so we'll get rid of that. So it shouldn't be spamming anymore. Okay, so then probably need to initialize the cursor state somehow, so let's do that. V main.c, so we'll have like an init cursor. Actually, we're going to put that in the terminal, and we're going to have cursor reset, because I happen to know already that there is a there is an escape code that is going to have to cause the cursor to be reset. So we will preemptively write this code. It's not really preemptive because I already need to do it. Where am I going to put this here? Cursor reset. This is going to take a key to cursor dot state. So what did I used to do here? Just straight up, just do this. So yeah, we'll do that. Except we don't have these things yet, so we'll just hard code these to. The background is going to be and dot A is going to be equal to that. And then the foreground I deleted the code. This one. Come on. Sometimes I'm not a fan of this. Why is that not? Okay, let me just. Not entirely sure if this is just ST or not. I'm gonna blame ST for it, to be honest. Anyways, okay. We're gonna do that. Then we're gonna close this window. In main.c, we are gonna call a cursor we're gonna call cursor reset here. Oops. Okay. We're gonna close this and we're gonna restart that so that the cursor is actually something reasonable. We are going to go to the debugger and figure out why there's no text. Yeah, let's break here. Okay, so we're gonna step into here. We're gonna get a line, get the cell size. We're gonna get the old cursor state. We need to do that before we do the allocate thing. Okay, so now if we do this, this should work. Nope. No, we still got the line, so we'll do this. Why is the cursor state wrong? Let me go back to the old main. We will shove a breakpoint. Yeah, that makes sense. Right. How annoying. Okay. Pass the cursor state into that function. Okay, so there we go. So starting to get somewhere. Except the starting position needs to be flipped. Where are we here? Let me do it this way. V2 starting position, so that we can position this where it's supposed to be, which is the top right corner, not the bottom left, or the top left, not the bottom left. So it's going to be position dot we're just going to make this the start position. Yeah, we're going to do this. Okay, we're going to do equal start position. Okay, so that's that. Keep our cell size. Here we're going to do It's probably going to be like really long and garbage, but anyways, window size dot I was going to start at 0 actually, so never mind. This part is fine. Yeah, that part is fine. It's just the Y position that needs to get flipped. That's not so bad. Okay. But we need to adjust this in here. The reason is that like the push line can move the cursor. So if we don't put this in here and the cursor moves, then we're not going to get the new starting position. Let me see here. Too few arguments. All right, so what did I pass here? Line and the start position. Now that's like way off screen for some reason. What did I do there? The start position's clearly wrong. It's cursor row +1. Okay. So there we go. That is where we want that to show up. Now we have to do some work to align stuff. But I already did this work. I deleted the work. Right, we're just centering it in the rectangle right now. Yeah, we don't want that. We do not want to center the thing in the rectangle. Okay, so now all the characters are lined up on the baseline like they're supposed to be. So that's good. And the color is different because I chose a different background color than the clear color. That's fine. Let us parse these color codes. So we are going to open terminal.c and go to close this and go to handle escape. So if the case is this character, actually just look here. So not that one, this one. yeah, so some of this stuff we're just gonna yank. Like that, this thing was this is showing up. This is whatever this GZ dead D4 thing is. Set primary, secondary, tertiary, or quaternary char set. Yeah, no. We have a single char set, and that char set is UTF-8. We're not going to be handling any of these weird alternate char sets. So yeah, we're going to skip over those ones. This one, on the other hand, we have to do something. So this one we're going to do handle CSI. And we're going to pass in raw and key. And we're going to break. Okay, so then for this one, okay. The VT320 allows the program to upload its own character set. Oh god. Yeah, that's definitely a thing that could be happening. I just want to handle the one thing right now. Okay. We are gonna go in here and we're gonna do CSI equals, so CSI is gonna equal parse CSI raw. We are gonna make a new type here that's gonna be CSI. Where do I want to declare this type? Don't really want to declare it in this header, to be honest. I'm just going to declare it here for now. CSI. CSI is going to have a few things in it. Where do we define it here? Okay, so we're going to do something like this. So, gonna store the raw process data. We're gonna store like these CSI commands. Let's just go here. Let's go to the top of this page. Doesn't make sense. Any of these pages like make it clear that that's what's happening? Not really. So basically, these CSI commands can be thought of as having like a an arg vector of different number of args. We are going to pound define arg size to be 6. This is mostly arbitrary. They're going to have a character representing the mode, and they're going to have another character representing if the mode's actually private mode. So you know, obviously, one mode was not enough. There had to be private mode as well as mode. It's like private mode is this is just like a flag that says that the mode is private. You know, just cause. Don't who knows. So we're gonna do this. We're gonna declare this. We're gonna write parse CSI. CSI. Parse CSI. I'm just gonna take an S8 pointer raw. And it is going to do a bunch of junk. I don't want to rewrite all of this junk, to be honest. It's going to declare CSI, and it's going to be empty to start with. Right. CSI to dot raw dot data is going to be equal to raw dot data. This is going to be annoying. We're going to call it r to data. And then we're going to do if a peak r 0 equals question mark, and then r equals consume 1, actually, get ASCII r is fine. And we're gonna do CSI.private equals 1, and we're gonna do CSI.raw.len plus plus. So we've consumed one character, and it set the mode to private. So there's our private flag. Let's actually bring these over here so I can show people what's going on here. So if we go here, first we got to look at what this like PS is. So PS means single optional numeric parameter composed of one or more digits. PM could be any number of single numeric parameters separated by semicolon. Individual values are PS. PT is a text parameter, so we're not going to have any text parameters so far for the CSI. Where is it? Where is CSI? Basically, what we need to do is go through and split up these numbers and then split up the mode. So move this back over here. While r len. We're going to do, here we're going to return CSI U32 code point equals get ASCII. We're going to increase the CSI to csi.raw.len++. And we're going to switch on the code point. I'm not going to do that actually. We're going to go if between code point 0 and 9, then so csi.argv dot csi.argv dot at the position csi.arg count. We're going to multiply that by 10. So if there's multiple digits, we're just basically parsing, just basically going to parse a thing like this. So if we had some random number like 123, first thing we're going to get is this 1. But argv just starts out, or sorry, argv starts out at 0. We're going to multiply it by 10 to shift over the digit by 1. And then we're going to set the digit. We're going to add, to the digit code point -0. So this is how you can convert these code points. This is like a convenience of ASCII, basically. We can look at the ASCII table. So 0, these show up as a sequence, 0, 1 through 9. So if you just subtract the character 0 from your code point, then you can get the number. We're going to do that. And then we're going to do what else did we do here? Yeah, we're just going to continue the loop, continue looping. Otherwise, if the character was not one of those, we're going to say if, we're going to increase the arg count. And then we're going to do so if the CP equals a semicolon, this is a nice bug actually in that old code. And ret.argc ret.argc does not equal escape buffer size. Escape arg size, I don't know what they called it. It should be called escape arg size. Yeah, okay. We can continue. Otherwise, this is kind of weird. If code point does not equal this, or ret.argc escape arg size, CSI.mode equals CP equals this. If it equals that, then we're going to use get ASCII on R. Otherwise, it's just going to be whatever that character was. I feel like the arg length is going to be 1. Incorrect here. No, it's not. Never mind. It's fine. No, it is. So if CP equals this, we need to do else CP CSI.mode equals code point. And CSI.raw.len plus plus. Okay. Return CSI. Otherwise, we'll continue looping. And we will return that junk at the end after we're done looping. Now, in some sense, though, there could be an error here. So if we actually don't return here, this is like an error case. Yeah, this is definitely like an error case. Needs more characters. Okay, so now we're gonna get our parsed CSI. And we're gonna say, let me see here. We're gonna switch on the mode. And then if it's M, so that's like the first one we just have here. If it's M, what's the function called? Why is this not on page? No, sorry, it's PM. Yeah, so that's why. Anyways, so this is gonna be set cursor mode or something. I think what did I call it before? Set cursor or set colors. Now let's stop passing that on the stack for now. Default. Unknown CSI, and we'll have a dump CSI function. What a mess. I copy this code because this is pretty good. So we're going to print raw escape. Then we're going to print the raw data. But if the thing is not printable, so if the character is printable, we'll print it. If the character is a /n, we'll put a //n. /r, put a //r. If it's something else, we'll just print the code point in hex. And then we're going to do the parse data as raw. So we're going to get the private, and then we're going to print the mode. Again, we're going to check if the mode is even valid. Yeah, yes, but so like select graphic rendition. I can put a comment here that it's like SGR. SGR is just like not very descriptive about what it's actually doing. Yeah, so let's see here. Yeah, print out the raw stuff. This is basically what we're doing here. So we're just gonna loop through all the args and print them out. And then we're done. That's gonna be the dump CSI function. Here we're gonna have the set colors. Maybe that needs to be below this function. Select graphics rendition. Like graphic rendition probably is correct. Okay, so this is going to take term pointer key and a CSI pointer CSI. Okay, so where are we here? I'm gonna pass this in. Oops. So set colors. I'll cover the rest of these later. I'll handle it after. So for argc, okay, so I'll include the cursor reset. Cursor reset, it's going to take the terminal pointer, and then we're going to break. Case 1, don't have any of these attributes defined yet. Add or null. Adder bold, italic, faint. Probably we'll just use the full name. Faint, underlined, blinking. This needs to be that. Blinking, or just blink. Adder inverse. Adder invisible. Adder struck. Yeah. Let me just have a look here. Okay. Is exactly what I did in a different order, but the order really does not matter. So we will take that as is. So adder 1 is going to be CS to adder or equals adder bold, a break, faint, 3, italics, so technically you could make the flags just like correspond to these, but like, yeah, it makes like completely no difference because you're still gonna have to go and like figure out what the bit was. So sorry, what was 5? 4 is underlined. Five is blink. Six does not exist. 7 is 7 is inverse. Don't even ask. I have no idea why 6 doesn't exist. I'd like have 6 even in this one. Probably not. Nope, no 6. 8 is invisible. And 9 is struck in. Struck. Okay. Oh, there's like rapid blink. Interesting. I don't think I'm gonna handle rapid blink differently from blink. So, if this ends up like needing, we can like have the we can insert like the case there at some point. But like we can insert the case there so it doesn't spam errors, but we're not going to set that different from normal blink. Okay, so default, what did I do here? Skip all this for now, and I'm just going to take this. Oops, let's go here and just put that. Sure. Okay, we need to have the isPrint macro. Util.c, util.h. That's a thing I did before, so okay. Yeah, isPrint is just between space and that tilde. Okay, let's see. I don't know why it's called colors right now. We're going to CSI to argv. Too much copy pasting. It's yeah, that's correct. 177. Correct. Okay. Raw. There we go. Now we've cleaned up all that junk around VTGL. And let me see here. What time? How long have I been streaming? 3 hours and 40 minutes. I think it's gonna be time to stop. That's a lot of blabbing. Yeah, cool. So say we're getting pretty close. We'll continue this tomorrow night probably, unless I'm like get owned at work tomorrow. Let's take the win. Let us take the win. So, let's see. Now, what happens if we just have some multiple lines actually first? Good. Let's fix that first before we go. Okay, so we're gonna get this up here and we're gonna do cat util.c. Oh, it's just that. It's just that problem again. What character did we just pass in here? 9. What's 9? Tab, sorry, horizontal tab. So yeah, we should replace that stuff with spaces again. So what was the call stack looking like? That was in push cell after push line. Okay. Push line. Yeah, so like I did cat KSH does have tab completion. It's like basic. You can add like custom tab completion. actually, I think I even have if config. Yeah, like I have custom KSH tab completion, but yeah, in this case, it's just the file contains tabs. Anyways, to do. Properly make sure characters are printable. Go back to this and we'll do another cat util.c. That might break. No, that's actually, okay, that's correct because I didn't, yeah. Let's advance the line as well. After each line. To do properly decide when to jump move lines. When to advance line. Advance row. Actually, we'll do that in here. Yeah, we'll do that here. Term t to cursor column plus plus. We're not like clamping it or deciding how many columns there are total or any of that. So this is not like gonna do the correct thing long term, but for now it's okay. When properly advanced cursor. And same thing down here. So do this. Oops. Oh yeah, so, okay. We need to reset the cursor and the row index. T to cursor. Before we blit lines, we'll set that to 0. Wait, why is there like some random... Where's the random white space coming from? There we go. Okay, so now let's see, oops, if we can cat util.c. So yeah, that's correct. So we're only printing 12 lines right now. This is hard-coded. We print, I don't know, 16 lines to get like some more space. So getting there, slowly getting there. Let's take the win. Yeah, let's take the win. We're doing good here. Oops. What am I doing? Okay. Let's just leave that there. We'll take the win. So what did we do? What did we do? Start parsing lines. Let's say start parsing color escapes. And we're not going to commit this thing. We're not using that flag right now. That's right. I think that's it. Start parsing color escapes. And start parsing color escapes. Let's just leave it at that, to be honest. So have a look at word count, the line count. This is the crap you got to deal with when you want to write a terminal emulator. 1,500 lines. Up to 1,500 lines of nonsense just to do this, and we're not even parsing half of the characters. We're not even doing half the things correctly yet. Anyways. Cool. Let's have a look. See here. See how many people are watching. See if we're going to do a raid. I think we are going to do a raid. There's a few viewers, so let's have a look. ASMR programming. I'm not too interested in that one. Do not speak Spanish, so that wouldn't be a good raid. Man, finding people to raid can be a bit annoying. In the software and development area. Lot of nonsense, lot of crap. Like, I don't care about, web programming or any of that JavaScript or any of that. Yeah, I'm not really seeing anyone doing anything particularly eye-catching. I mean, there's Sneaky Donkey. He's been streaming forever. He'll probably be ending soon. This guy, he's doing like QEMU Linux kernel stuff. Thread synchronization ordering. Let's have a listen and see if he sounds like he's staying around. He's not doing anything. Okay, we're just gonna leave it off. Leave it off there then. Thank you everyone for watching, and I will hopefully see you around on the next one. And we will continue working on the terminal emulator. So, see y'all later.